There is a place on Earth where no human eye has ever adjusted to the darkness. Not because we haven't tried, not because we lack the technology, but because in this place there is no darkness to adjust to. There is only absence. Imagine standing at the edge of a cliff you cannot see. The air is gone. The ground beneath you isn't ground at all. And if you listen closely enough, you might hear something moving in the nothing. Something that has never known the sun. Something that has been evolving in total isolation for hundreds of millions of years. Right now, beneath the surface of our oceans, there exists an entire world that operates on rules we're only beginning to understand. A world where eyes are useless, where light is a weapon, where the very concept of up and down loses meaning. And in this world, creatures have learned to do things that should be impossible. They generate their own light in a place that has never seen a star. They survive pressures that would crush a tank like a paper cup. They hunt without seeing. They communicate without sound. Some of them are older than mountains. Some are transparent. Some have evolved features so alien, so utterly divorced from anything we understand about life on the surface, that when scientists first pulled them from the depths, they genuinely weren't sure if they were looking at one creature or several fused together. This isn't science fiction. This is the deep ocean, and you're about to descend into it. What you're about to discover will change the way you think about life itself. Because down there, in the crushing, lightless depths, evolution didn't just adapt to the darkness, it thrived in it. The question isn't whether life can survive where light never reaches. The question is, what has it become?
Let's begin the descent. You're standing on the deck of a research vessel, somewhere in the middle of the Pacific. The water is calm, blue, almost inviting. You slip beneath the surface. For the first few meters, everything feels familiar. Sunlight penetrates the water in shafts of gold and turquoise. Fish dart past. The ocean feels alive. But keep going. At around 200 meters down, something changes. The blue begins to fade. The gold is gone. You've entered what scientists call the twilight zone, a band of ocean where light still exists, but only barely. It's dim, ghostly. And this is where the rules start to break. Because here, in this fading light, creatures face an impossible problem. If you have eyes, predators can see you. If you have a shadow, you're a target. And in a place where there is just enough light to be seen, but not enough to hide, evolution had to get creative. Enter the hatchetfish. This small silver creature looks like it was designed by someone who understood physics a little too well. Its body is flattened, blade thin, almost invisible from viewed below. But that's not the strangest part. Along its belly, the hatchetfish has a row of light-producing organs called photophores, and these lights do something remarkable. They match the faint glow of sunlight filtering down from above. It's called counter-illumination. The hatchetfish is actively erasing its own shadow. Think about that for a moment. This fish is generating light not to see, not to attract prey, but to become invisible. It's measuring the brightness of the water above it and adjusting its own bioluminescence in real time to blend into the background. It's a living camouflage system that works in 3 dimensions, and it's been doing this for millions of years. But the hatchetfish isn't alone. All around it, other creatures are playing the same game. The viperfish, with fangs so long they can't fully close their mouths. The bristlemouth, possibly the most abundant vertebrate on the planet, numbering in the hundreds of trillions. The lanternfish, migrating upward every single night in swarms so massive they confuse sonar systems. This is the largest animal migration on Earth, and most people have no idea it's happening. But here's the thing. The twilight zone is still the easy part, because below this, the light doesn't just dim, it dies. 1,000 meters down, you've crossed a threshold. There is no more sunlight, not a glimmer, not a trace. The water pressure is now 100 times stronger than at the surface. The temperature has dropped to just above freezing. Welcome to the midnight zone. And here, something extraordinary happens. In a place with no light, nearly 90% of the creatures produce their own bioluminescence. It's one of the most widespread adaptations in the deep ocean, and yet scientists still don't fully understand how or why it evolved so universally. Some use it to hunt, some use it to confuse, some use it in ways we're only beginning to decode. Take the anglerfish. You've probably seen pictures, bulbous body, gaping mouth, and that glowing lure dangling in front of its face like a deep-sea lantern. But what you might not know is that the light isn't coming from the anglerfish itself. It's coming from bacteria. Inside that glowing lure, called an esca, lives a colony of bioluminescent bacteria. The anglerfish provides them a home, a steady supply of nutrients, and in exchange, they glow. It's a partnership, a symbiosis forged in total darkness. And the anglerfish uses that light like bait. Small fish, curious and hungry, drift toward the glow, and the anglerfish waits, perfectly still, mouth open, until the prey is close enough. Then it strikes. The attack is over in milliseconds. But here's where it gets stranger. In many species of anglerfish, only the females have the lure. The males are tiny, sometimes 100 times smaller, and they live a very different life. When a male finds a female, he doesn't just mate with her, he fuses with her. He bites into her skin, and over time, his body merges with hers. His bloodstream connects to hers. His organs dissolve. He becomes a permanent appendage, existing only to fertilize her eggs. He gives up his independence, his identity, everything except his ability to reproduce. Scientists didn't believe this was real when they first discovered it. It seemed too bizarre, too extreme. But down here, in the midnight zone, extreme is the baseline. And then there's the vampire squid. Despite its name, it doesn't suck blood. It doesn't even hunt living prey. Instead, it drifts through the water collecting marine snow, a continuous rain of dead plankton, feces, and organic debris falling from the upper layers of the ocean. It's eating garbage, and it's thriving. The vampire squid has the largest eyes relative to body size of any animal on Earth. Massive blue alien eyes designed to detect the faintest bioluminescent flickers in the dark. When threatened, it doesn't flee. It turns itself inside out. Its arms curl backward over its body, revealing rows of fleshy spines. It becomes a living nightmare, pulsing with bioluminescent light, confusing predators just long enough to escape. But even this isn't the deepest we can go, because beneath the midnight zone lies something even more unforgiving, a place where the very concept of survival seems to break down.
4,000 meters. The pressure here is roughly 400 times what you experience at sea level. If you were somehow transported here without protection, your lungs would collapse instantly. Your bones would compress. Your cells would rupture. And yet, life is here. Not scattered, not rare, thriving. This is the abyssal zone, a cold, high-pressure desert that covers more than half of the Earth's surface, and the creatures here have evolved solutions to problems we didn't even know existed. Consider the pressure. At these depths, the ocean is pressing down with a force of several tons per square inch. For most life, that's instantly fatal. But deep-sea creatures don't fight the pressure, they equalize it. Their bodies contain no air pockets, no compressible spaces. Their cells are filled with specialized proteins and organic molecules that stabilize under extreme pressure. Some fish have replaced rigid bones with soft cartilaginous skeletons. Others have gelatinous bodies that compress and flex with the water around them. They don't resist the abyss, they become part of it. And then there are the scavengers. In the deep ocean, food is scarce. A dead whale falling from the surface is like a skyscraper made of meat suddenly appearing in a barren wasteland. When a whale carcass reaches the abyssal floor, it triggers an event called a whale fall, and the response is immediate. Within hours, hagfish arrive, primitive eel-like scavengers that burrow into the carcass, eating it from the inside out. Sleeper sharks circle, tearing off massive chunks of blubber. Crabs swarm, worms colonize the bones. A single whale fall can sustain a localized ecosystem for decades. But what happens when even the whale falls run out? Some creatures have learned to wait. The giant isopod, a deep-sea relative of the pillbug, can survive for years without food. It enters a state of near hibernation, slowing its metabolism to almost nothing, waiting in the dark for the next meal to arrive. Patience down here is a survival strategy. And then there's the Dumbo octopus. Named for the ear-like fins that flutter on either side of its head, this small, ghostly creature hovers just above the seafloor, hunting for worms and crustaceans. It moves with an eerie grace, almost peaceful, but it lives at depths where the pressure would kill almost anything else. Scientists still don't fully understand how its soft body withstands the crushing weight. There's something in its cellular structure, something we haven't completely decoded, that allows it to exist in a place that should be incompatible with complex life. But even the abyss has a floor, and beyond that floor, there are trenches. Cracks in the Earth's crust, so deep, so isolated, that they represent the most extreme environment on the planet. And somehow, impossibly, life found a way down there, too.
6,000 meters. 7,000. 8. You're descending into the Hadal Zone, named after Hades, the ancient Greek underworld, and the name is fitting. These are the ocean trenches, narrow, deep scars in the earth where tectonic plates collide and one is forced beneath the other. The Mariana Trench, the Tonga Trench, the Philippine Trench. Places so deep that if you dropped Mount Everest into them, the peak wouldn't break the surface. The pressure here exceeds 8 tons per square inch. The temperature hovers just about freezing. There is no light, no surface connection, no photosynthesis. And yet, in samples taken from the very bottom of the Mariana Trench, nearly 11 kilometers down, scientists found life. Not just bacteria, fish. The Mariana snailfish holds the record as the deepest living fish ever recorded, filmed at a depth of over 8,000 meters. It's small, translucent, almost gelatinous. Its bones are thin and flexible. Its body lacks scales. It looks fragile. But fragile is exactly what allows it to survive. The snailfish has adapted to the pressure by eliminating rigidity. Its tissues are soft, its skeleton minimal. It doesn't need armor, it needs flexibility. And it's thriving in a place where, by all logic, complex life shouldn't exist. But the snailfish isn't alone. At the bottom of these trenches, scientists have discovered entire ecosystems built around hydrothermal vents, underwater volcanoes that spew superheated, mineral-rich water into the freezing abyss. These vents were first discovered in the late 1970s, and they changed everything we thought we knew about life. Because the creatures living around them don't rely on sunlight, they rely on chemosynthesis. Bacteria at these vents convert chemicals, hydrogen sulfide, methane, into energy, and in doing so, they form the base of an entire food chain. Tube worms, some growing over 2 meters long, host these bacteria inside their bodies. Yeti crabs farm bacteria on their own arms, waving them through the vent water like underwater gardeners. Life here isn't just surviving, it's flourishing, and it's doing so using chemistry we thought was impossible for complex ecosystems. This discovery had profound implications. If life can exist in the crushing, lightless, chemically hostile environment of a deep-sea vent, then maybe it can exist in the subsurface oceans of Europa, or Enceladus, or anywhere in the universe where liquid water and energy meet. The deep ocean didn't just teach us about Earth, it taught us about the possibilities of life itself. But even now, after decades of exploration, we've mapped less than 20% of the ocean floor. We know more about the surface of Mars than we do about the deepest parts of our own planet. And every time we send a submersible down, we find something new, something unexpected, something that forces us to rewrite the rules.
So here's the truth. The creatures that live where light never reaches aren't just surviving in an alien world. They are the alien world. They've evolved senses we can't imagine. They've developed partnerships with bacteria that glow in the dark. They've learned to hunt without eyes, to navigate without landmarks, to thrive under pressures that would annihilate us. And they've been doing it quietly, invisibly, for hundreds of millions of years. But we still don't know how many species live down there. We don't know how deep life can actually go. We don't know what's happening in the unmapped trenches, the unexplored ridges, the vast stretches of abyssal plain that no human has ever seen. Every year, scientists discover new species in the deep ocean, not just one or two, hundreds. And each discovery raises more questions than it answers. How did the snailfish evolve to survive at such depths? What communication methods are we missing because we can't detect them? Are there entire ecosystems we haven't even imagined yet? The deep ocean is a reminder of how little we actually know. It's a reminder that Earth still holds mysteries, that there are frontiers we haven't crossed, that the strange, the unknown, the impossible is closer than we think, just beneath the surface, waiting in the dark. And maybe that's the most unsettling part. These creatures have been there all along, evolving, adapting, thriving, in a world we never see, in a place we'll never fully understand. So the next time you look out at the ocean, remember, you're not looking at the surface of something simple. You're looking at the ceiling of the largest, strangest, most alien habitat on Earth. And beneath it, life is doing things we haven't even begun to comprehend.